Hi and welcome to Study Room. I am Prataksha, your chemistry teacher, and today I'll be discussing with you the chapter Combustion and Flame. Now, in the previous chapter, we had a look at our fossil fuels, the natural resources, the exhaustible natural resources that we need to use with very caution. Okay, and we know that we apply the use of fossil fuels for the production of various other products, and mainly fossil fuels, they are burnt to produce heat and energy. And this heat and energy is later used for the manufacture of various other products. In this chapter, we will be discussing the process by which this heat and energy is released, by the process of combustion. And we will be also having a look at the term flame. What does flame signify? And also, we will be learning about ignition and ignition temperature. So let's get started. Different kind of fuels are used for various purposes at home, in industry, or for running automobiles. And the various kind of fuels that are used for these purposes, we have already had a look at this in the previous chapter. So let's revise, right? So for home, we know that we use LPG, the liquefied petroleum gas, and in some areas like Vadodara, there is also the usage of CNG via direct pipelines, right? And in industry, we also use a lot of petroleum products for our for the manufacture of all those items which require fossil fuels. And along with petroleum, we also use coal, right? For running automobiles, we use petrol or diesel, and also CNG, right? So these are the different kind of fuels that are used for the various purposes, be it at home, be it in industries, and for running automobiles. All right, but what is the process by which these fuels or these fossil fuels? What is the process by which these fossil fuels are used for the production of heat or for the production of energy? Because we know that the release of this energy is utilized for the running of automobiles. It is utilized for the running of machines, different machineries in industries, and also for cooking food at our homes. And the heat that is released it also renders it renders the temperature high, it renders the products high, and then it is also used for the various other purposes and manufacture, right? What is the difference between the burning of a candle and the burning of a fuel like coal? All right, so we know that the fossil fuel that we get, coal, it has many industrial applications. Okay, it is used in industries. In earlier times, it was used in railway engines, right? And also candle is mainly a paraffin wax, right? That petroleum product known as paraffin wax. Okay, but you must have observed that candle, when you burn the candle, it burns with a flame. All right, this is your flame. Whereas coal does not burn with a flame. But why is it so? Okay, candle burns with the flame, whereas coal does not. Similarly, there are many other materials that burn without a flame. So in this chapter, we will be particularly looking at those items that burn with a flame and those items that burn without. And though for those items that burn with the flame, what is this flame? All right, what is this flame and how is it being produced? Okay, and what is the difference between those items that burn with the flame and those which do not? Okay, burning of a charcoal. For this experiment, you take a piece of charcoal and you hold it with a piece of iron tongs, and then you bring it near a flame of a candle, and then you observe you observe the process by which it is being burnt. So you will notice that charcoal is burning in air when you bring this piece of charcoal towards a lighted candle. Okay, and you will observe that while it is burning, it is producing some gas, some heat, and light. This gas that is being produced when you burn a piece of charcoal is none but the carbon dioxide. And if you remember that magnesium burning of the magnesium ribbon experiment that we had done in the previous chapters, you know that magnesium burns in air to form magnesium oxide, and also carbon dioxide is being released, right? Similarly, when charcoal is burning in air with the presence of this heat provided by the candle, then also you will notice that carbon dioxide is being produced, and it burns with heat and light. Okay, now this now brings us to the process about which I have been talking about, okay, that is combustion. So this burning of various fuels like coal, like even wax, okay, even the paraffin wax, that candle. So when it is burning, there is a chemical reaction going on, because the wax that was there earlier, okay, or for example the coal that was there earlier, when you burn it, the result that you get, those ashes, they are not the same as the reactants that were there before. Means the ashes, they differ from the coal before the coal was burnt. Okay, so there is a chemical process going on, some chemical reaction is going on, in which the substance, whatever substance which you are allowing it to burn, it reacts with atmospheric oxygen to give off heat. And this process in which heat or energy is being released, this process is called combustion. So while introducing this chapter, I told you that in the previous chapter we had learned about fossil fuels, and we know that fossil fuels, the wide applications of fossil fuels, it is mainly applied by burning them to produce what? Heat and energy. And this process by which these fossil fuels, they interact with oxygen to produce heat and energy, this process is known as combustion. And you have to remember that combustion is not a physical process, rather it is a chemical process, means the product that you're getting will be different than what the initial reactant was before it reacted with air to produce energy, heat, or sometimes light is also produced during combustion. Okay, sometimes light is also given off during combustion, either as a flame that we will be learning about, that candle flame, okay, or as a glow which we saw in the case of coal, because we saw in the previous slide that coal does not burn with the flame, rather it glows when it is heated, and candle, it burns with a flame. So for example, over here, if you talk about any fuel like wood or coal, you know that it has the presence of hydrocarbons, right? So hydrocarbons, they react with oxygen, they go undergo the process of combustion, okay, and this is a chemical process because the resultant that you are getting is different than the reactants. You are getting as a result carbon dioxide gas, and you are also getting water. Okay, what is a fuel? You already know that what is a fossil fuel. You already know that how fossil fuels are formed, and you know that these fossil fuels, they are used for the production of heat and energy, so that other products, they are formed. All right, so you know that these fossil fuels, since they are burned, since they undergo that process of heating in order to produce some results, that the desired results of heat, desired result of energy, and desired result of light. Okay, so basically this fuel is undergoing a process of combustion. All right, so substance that undergoes combustion is said to be combustible. Okay, means the substance which is capable of undergoing the process of combustion, that substance is capable of reacting with oxygen in order to burn, in order to produce heat and energy. That substance is known as combustible. And those combustible substance that we utilize for our purposes, what kind of purposes? At homes, for our domestic purposes, also for industrial purposes, all right, and also for the running of our vehicles or automobiles. Okay, so those kind of products that we are using for our household purposes, industrial purposes, or for the running of automobiles. So those kind of processes that undergo combustion to provide our need, to fulfill our desires, to fulfill our needs, those products, they are known as fuel. And what are the common types of fuels? We have already had a look at this. The common types of fuels, they are wood, charcoal, petrol, kerosene, etc. They could be either solid, liquid, or gaseous in state, because wood, you know, is solid, kerosene is liquid, and gases like LPG, gases like CNG, they are in the gaseous state. Okay, magnesium and charcoal mentioned in the previous activity, where we saw that magnesium burns in air to produce carbon dioxide, and charcoal also does the same. So they are also the solid combustible substances. So I'm repeating this for you. Those substances that undergo the process of combustion to produce heat and energy and sometimes light, they are known as combustible substances. And these combustible substances, which we employ them for our use, for what uses? For uses in at our domestic purposes, for in order to cook food, and in our industrial processes, and in for our vehicles to run, for our engines to run. Okay, for these processes, they are known as fuels. Okay, is food fuel for our body? We know that whatever kind of fuel we are applying for our purposes, okay, they are basically producing what? They are basically producing energy and heat. And this energy and heat is what is being employed in order to produce other products, right? In our body, when we eat food, this food the products of this the food items, the products like what? Products like carbohydrates, proteins, all right, all those small nutrients that we have, be it macro or be it micro, they are reacting with oxygen, and they are reacting with oxygen to produce energy, to produce heat. So whatever activities that we do, even I'm talking to you, right? This is also an activity. This is also an activity that requires energy, that requires heat. So where am I getting this energy to talk to you? I'm getting this energy to talk to you because of food, because food is the fuel for my body. Food is the fuel for my body means food provides energy and heat for my body, and so that I am able to perform various tasks. All right. So in our body, food is broken down by reaction with oxygen, and heat is produced. And like you can see here in this cute animation, we eat food so that we get energy, so that we gain energy, and this energy, we employ this energy for our various chores that we do during our days. Combustible and non-combustible substances, we will be having a small activity, a small experiment where we will be looking that what are the products that undergo the process of combustion readily, means what are the combustible products and what are the non-combustible products. Okay, for this experiment, collect some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, etc. And then you try to burn them, and be careful while you try to burn each of these items. And after that, you decide that whether they are combustible or not. Okay, so I will be giving you a nutshell where I'll be explaining you which are the combustible items and which are not. If you wish to do it, you may also do it at your home under proper precautions and proper care. Okay, be careful. So wood, when you burn wood, you know that wood is a combustible substance, right? Meanwhile, paper. What happens when you burn paper? Paper is also able to burn readily to produce heat and energy, right? So paper is also combustible. But if you burn an iron nail, would it also go the process of combustion soon? No, right? It will take a lot of time, and if you just keep a matchstick or a lighter near an iron nail, it will get hot, but it won't burn. It won't burn to produce energy and heat. Those two products that are there when a product is undergoing combustion. So iron nail is a non-combustible product. Kerosene oil is readily combustible. Stone piece is not combustible. Straw is also readily combustible. Means all of these items, wood, paper, kerosene oil, straw, they are undergoing the chemical process of combustion in order to produce energy, heat, and sometimes even light. Whereas iron nail and stone piece, they do not. Also, matchsticks, they are combustible. Charcoal, your coal, they are combustible since they contain hydrocarbons, and glass pieces, they are not combustible. Okay. Is air necessary for combustion? Now that we have established a definition of combustion, we have seen how combustion occurs, and we have seen what are the products that are combustible and what are the products that are not combustible. We will be now learning about the three requirements, the three requisites for combustion, and we'll be learning about them one by one. So the first requirement is air. The first requirement is oxygen that is present in the air. For this, to determine this, we will be looking at a simple experiment. Fix a lighted candle on a table. Like you can see here in this animation, we are taking a lighted candle and we are putting it on a stand. And then we are putting a glass chimney over it. Alright? And we are lighting the candle. So first that candle is lighted, and then we are putting it on a stand and we are placing a glass chimney over the lighted candle. In the first case, you rest that glass chimney on a few wooden blocks, in such a way that air is able to pass through the bottom part of a setup. As you can see here in this animation, when the first case scenario appears, and it's gonna appear soon, so you will be seeing that setup that I'm talking about. Okay, so here the first case, you have placed wooden blocks so that air is passing at the bottom of the glass chimney. Okay, in the second case, you remove those blocks, and in the third case, you put a piece of glass, as you can see over here, a glass or wood, anything. Okay, you basically block the glass chimney from the upper side. Then you observe that what is happening. You will observe that in the first case, when you had put those tiny blocks so that air was passing from beneath, okay, in that case the candle will continue to burn. In the second case, when you had removed those blocks and there was just that tiny the tiny hole in that glass chimney, all right, so that was not sufficient for the air to pass through. So after a while the flame will flicker and it will produce smoke, means it will ultimately extinguish, all right. And in the third case, when you had blocked that glass chimney from the top as well, you will notice that the flame will quickly extinguish because the supply of air is directly cut off. Okay, so this experiment demonstrates, it demonstrates that air is necessary for combustion, because in the first case, when we allowed the air to pass beneath from so if this is a glass chimney, okay, and if here is a candle, all right, and we had placed wooden blocks, and this was a slab on which the candle was resting. This is a poor drawing, but I hope you get the concept, right? So we were basically allowing the air to pass beneath it, so that this candle setup, it was getting air, it was getting oxygen for combustion. In the second case, when we had removed these blocks, so we had basically stopped our supply of air, all right, and from the top also, since the hole, as you can see in this picture, it's not so wide. Observe the second case, right? The candle will flicker and then it will extinguish, producing smoke. See, okay. And in the third case, when we had totally blocked the supply of air from beneath as well as from the top, the candle immediately extinguishes, because after whatever oxygen is left in this glass chimney, after that is employed or after that is used up, consumed by the candle in order to burn, after that is consumed wholly, there is no oxygen left, there is no air left, and hence the candle will extinguish. And there is a fun fact for you, that the sun produces its own heat and light. In the sun, heat and light is produced by nuclear reaction. So there is no any external setup for the sun in order to produce heat and light. It is a self-sustaining source of heat and light, is a self-sustaining source of undergoing constant combustion. And how is this combustion process carried out in the sun? It is carried out via nuclear reactions, via some fission and some fusion. Okay, these are the kinds of nuclear reactions. All right. Now, we will demonstrate and we'll have a look at another activity with a piece of burning wood to demonstrate that air is required for combustion. So we place a burning wood or charcoal or an iron plate or a tawa, and then after burning, we cover it with a glass jar or a tumbler so that the supply of air is stopped. Okay, and we will notice that after some time, means after the coal has consumed all the air that was available within this glass tumbler, after it has consumed all that, the charcoal will stop burning, and this shows that burning requires air. So air is our first requisite, or oxygen basically that is present in the air is our first requisite in order for combustion to take place. Okay. When the clothes of a person catch fire, the person is covered with a blanket. Do you know why? Because you know now that air is the prerequisite for combustion, right? So if a person whose clothes are on fire, all right, if his clothes or her clothes, they're burning, and if you immediately cover that person with a blanket, so you're basically using this blanket to stop the contact of the fire with air, all right. So you're basically using that blanket as a covering source, as a protecting source. You are not allowing that fire, you're not allowing that fire to come in contact with air, because now there is a presence of blanket in between this fire and the outside air. All right. So when you cover this person in blanket, you will see that the fire is extinguished, because the air which the fire was using in order to keep burning, its supply has been immediately stopped. Okay. Why do you have to use paper or kerosene oil to start fire in wood or coal? You will observe that um, when you wish to say start a fire on wood or coal, it will require more time. You will have to like keep on waiting with the. It's not possible if you just bring a matchstick to a piece of wood or a piece of coal and you wish for them to burn. So it will take a lot of time. Okay, but rather, if you use paper or if you use kerosene oil, which is readily flammable, which readily produces fire, all right, and when you keep that piece of wood or that piece of coal near to this burning paper or kerosene oil, the source of burning kerosene oil, then after some time, you will notice that they will automatically start burning. This is because there is something that we call as the ignition temperature, which we will be learning in this chapter. That is the minimum temperature that is required for a substance to catch fire and to keep burning on its own. Means that if you supply fire to say a piece of coal, all right, then you have to keep supplying the source of fire to the coal, so that after some time it finally starts burning on its own. Means after some time you don't have to constantly supply that source of fire to the coal. It will start burning on its own. It would not need any external source. Okay, so the minimum temperature at which any substance it starts burning on its own. Okay, it is sustainable of burning on its own in order to produce what? In order to produce heat and light. So it is sustainable in order to produce in order to undergo combustion basically. Okay, so that minimum temperature is known as ignition. And in the case of paper or kerosene oil, this ignition temperature is very low, and in the case of wood or coal, this ignition temperature is very high. So if you take a piece of take a lighter or take a matchstick, and you wish for that piece of wood or for that piece of coal to burn, it will take a lot of time, because its ignition temperature is high. Means that you have to supply the constant source of heat for a longer time in the case of wood or coal. Okay, but if you burn a piece of paper, or if you take some kerosene oil and put fire to it, and then you bring that wood or that coal near to that burning paper or burning kerosene, so you are supplying that piece of wood or that piece of coal with some source of heat. Means you won't have to work to, you won't have to like wait, you won't have to go yourself and bring a matchstick near and keep on holding it, that when will the wood burn or when will the coal burn. All right, you have supplied the source of heat to the wood or the coal via this paper, via this kerosene oil. Okay, and after some time, when that wood or that coal gets hot enough so that its ignition temperature is increased or its ignition temperature is reached, it will start burning on its own. Means after that time it would not even require this piece of paper or that source of burning kerosene oil. Okay, we will be discussing this concept later on in more clarity, but I hope you have gotten a gist of what I'm trying to say. And lastly, for this part of the chapter, we will be learning about forest fires. So you must have heard, especially in South America, that forest fires, they are the source of a lot of burning and the loss of a lot of trees and a lot of animals. Okay, so what happens is that during extreme of heat, some dry grasses or some pieces of dry, you can say shrubs. Okay, in the case of direct sunlight, in the case of very extreme heat, extreme temperature, they start burning on its own, because the ignition temperature of this dry grass is very low. So in the case of extreme heat and extreme temperature, they start burning. And when they start burning, since there is no source to extinguish this fire, means there is no source to stop the supply of oxygen. So what will happen? The fire will start burning, and slowly when it reaches tall trees, and you know that obviously the ignition temperature of a grass would be very very low, as the ignition temperature of grass would be very very low as compared to tall trees. All right, but if say a tree is surrounded by dry grass, and all of that dry grass is burning, So ultimately, over a period of time, those trees would also be heated up to such a temperature that they reach their ignition temperature. And once that is reached, then trees will also start burning. All right. So this is sort of a chain reaction. One thing catches fire, and there is nothing to stop the source of fire. All right, to extinguish that source of fire, and the other thing also then catches fire, and everything starts burning. All right. So forest fires, this is how forest fires they are started, and it's very difficult to control such fires because when we humans get to know that there is a forest fire, what happens is that most of the vegetation around that area is already burning or is already burned even as at some times. Okay, so it's very difficult to determine and detect forest fire, and especially very difficult to control fire. Now, in the further parts of the chapter, we will be learning about ignition, we'll be learning about flame, and we'll be learning about many other things. Okay, so till now, I hope you have got this idea clear that what combustion is. Okay, and why do we supply a piece of paper or some source of burning kerosene oil to the wood, and also how forest fires, how they occur.